Now we're going to talk about other exponential functions, and these functions are more realistic. Most exponential functions do not take into account factors that will limit growth. For example, in population, populations can't grow infinitely. Just as money will not grow infinitely, they all will reach a limit. And specifically in population, uh, there are factors that will limit population. It will not let it grow infinitely. Factors like the food supply, sickness, viruses, etc. And here I have a graph on the prey versus predator cycle, and this is a model that shows how the population of hares or of rabbits changes in comparison to how the population of wolves, of the predator, changes. Okay, so in this case, notice how there are a lot more rabbits in the world than there are wolves. But the population of rabbits, notice here when it reaches its peak, right? When it reaches its peak, it corresponds with a very low population of wolves. So since there are not that many wolves, this population of rabbits is able to grow because there's less predators. Now, when there are a lot of hares, notice how this population of wolves starts growing because there's more food supply. So that means I'll have more wolves because I have more food supply. And then the cycle goes as the predators' population diminishes, the population of hares increase again because there's less predators. So this is a more realistic model of population growth, taking into consideration food supply, sicknesses, and viruses. And we have an example. The population of fish in a certain lake at time t months is given by this function. Now there's an upper limit on the fish population due to the oxygen supply, available food, etc. Graph the function and find the upper limit on the fish population. So we're going to graph this function using WZ Grapher, and you'll see that you'll have a graph that will reach a certain limit. It will not grow infinitely. So let's do this graph in WZ Grapher and then come back. Here's the graph on that fish population model that we were talking about. It said that there was an upper limit on how many fish can survive in this lake. And if I look at this graph, notice this graph starts off as an exponential growth graph, but at a certain time, at a certain x value, this exponential function will reach an upper limit, and that means this population will grow to a certain number and then it will remain at that number. Now, why is this? Because food supply, oxygen supply in the lake, too many fish, not enough oxygen for all those fish, not enough food for all of them. So this is how it will behave. This lake will be able to supply for 20,000 fish, and that's it. So this is a more realistic model. This is called a logistic model where it takes into account other factors. It will not grow infinitely. And notice as x approaches maybe 31, 32, and remember x is my t value for my function, which is the time, and this is months. So when x is about 30 months, which is 2 years and a half, the lake will have a maximum of 20,000 fish in the lake. Okay, so this is the maximum amount of fish that will be in the lake given this model. Okay, very interesting. This is more realistic. And the same thing happens when we'll see some applications with money where we invest money at different interest rates, and we think that if we compound the interest like every second, we will make money grow faster or grow more. And you will notice that it will also have an upper limit. Okay, it will approach a certain value and remain there. So there you have it. I hope you liked this example, and if you need to go back, go ahead and do so. Goodbye.